Formed over hundreds of millions of years, abundant coal reserves underlie much of Appalachia, the Midwest, and the Rocky Mountains in America. Each year, more than 1 billion tons of coal are mined in the U.S. America has enough coal to last hundreds of years. Nearly all of the nation's coal is used to generate electricity, and most of the electricity Americans use comes from coal. Coal helps Americans enjoy some of the lowest electricity rates in the world. The value of coal lies in the amount of energy released when it burns. The energy in America's coal deposits is greater than the energy in all of the world's oil reserves.
Unfortunately, not all of the energy in coal can be captured. The universal, unchanging laws of thermodynamics prevent it, but the efficiency of coal utilization can be improved. This is one of the key challenges facing the National Energy Technology Laboratory and America's coal researchers.
Today's fleet of coal-fired power plants averages 35% efficiency. Through collaborative research with the private sector, NETL expects to push this percentage to 50% and beyond. This is highly significant. In terms of greenhouse gas emissions, each 1% improvement in fleet efficiency is like removing 11 million cars from the road. Even with greater efficiency, coal-fired power generation, like all power generation, has environmental challenges. Coal is not a pure substance. Though coal is composed mostly of carbon, it also contains trace amounts of other elements, including mercury, nitrogen, and sulfur. When coal is used to generate electricity, these elements can form harmful compounds like nitrogen oxides and sulfur dioxide. It also produces the greenhouse gas carbon dioxide and very fine particles that can foul the air. NETL and America's coal researchers are developing technologies to reduce these air and other emissions. They are working to minimize the impact of electricity generation on the nation's water resources. And they're finding new beneficial uses for solid byproducts of coal combustion. Through improvements in efficiency and technologies that reduce emissions, the coal-fired power plants of tomorrow will be virtually pollution-free. Introduced in 1792, gasification is a process that converts coal and other carbon-based materials into synthesis gas, or syngas, which is a mixture of carbon monoxide and hydrogen. Once processed, coal gas can be used as a versatile ultra-clean fuel for generating electricity, manufacturing chemicals, and as a fuel source for vehicles in the transportation industry. In the 19th and early 20th centuries, coal gas was used to illuminate street lamps, warm homes and businesses, and power industrial steam engines. By the 1960s, coal gas was replaced by oil and natural gas as our nation's primary suppliers of power, heat, and light. Modern gasification technologies, diminishing supplies of oil and natural gas, and the rising cost of these fuels have renewed interest in producing coal syngas as a desirable alternative. In the modern gasification process, coal is fed into a gasifier and exposed to steam and oxygen at high temperatures and moderate pressure. Under these conditions, a series of chemical reactions occur that break the coal down into its base components: hydrogen, carbon monoxide, sulfur, and mineral impurities. The syngas is then cleaned to remove these impurities, which can be used to produce fertilizers, construction, and road building materials. Coal syngas is used in a modern turbine power plant called an Integrated Gasification Combined Cycle, or IGCC power plant, which is today's environmentally preferred method for producing electricity and manufacturing chemicals. IGCC gasification is the primary technology component of FutureGen, the Department of Energy's zero-emissions power plant. Coal syngas can also be used to refine natural gas for home heating and industrial use, to produce hydrogen and other transportation fuels, and as the base component in chemical processes that create a multitude of everyday products, from plastics, solvents, and adhesives, to cosmetics, artificial sweeteners, and pharmaceuticals. The greenhouse effect is the process by which an atmosphere warms a planet. It is a natural process that makes Earth suitable for life as we know it. Earth receives energy from the sun. The Earth absorbs most of the solar energy and releases it in an infrared radiation. some of the infrared radiation goes back into space. About 1% of the Earth's atmosphere is made up of greenhouse gases, primarily water vapor, carbon dioxide, methane, nitrous oxide, and ozone. These gases absorb some of the infrared radiation from the Earth and re-emit the energy as heat. Without this warming, the Earth would be about 60 degrees Fahrenheit colder than it is. At issue is the role of humans in advancing the greenhouse effect. Methane is produced when bacteria breaks down organic matter. About 1/4 of global methane emissions from human activities come from livestock and the decomposition of manure. Although methane is emitted into the atmosphere in smaller quantities than carbon dioxide, it is over 20 times more potent as a greenhouse gas. Trees remove carbon dioxide from the air through photosynthesis. As large forests are cleared worldwide, fewer trees are available to clean the air. Most of the carbon in burned or decomposing trees escapes into the atmosphere. About 3/4 of humankind's carbon dioxide emissions come from fossil fuels. Burning coal, oil, and natural gas provides energy to produce electricity, heat our homes, run our automobiles, and power factories. Global climate change has taken center stage as an issue for debate throughout the United States and around the world. While coal-fired power plants and other sources emit carbon dioxide and other greenhouse gases into the atmosphere, governments, industry, and the scientific community search for ways to mitigate the effects of those gases on our environment. NETL ties its efforts into a network of 7 regional partnerships that address sequestration issues and technologies relevant to each of their areas of the country. And all of these efforts will be integrated into a power plant of the future concept known as FutureGen, an ultra-clean plant that will both sequester greenhouse gases while producing hydrogen for use in industry, transportation, and stationary power. Several NETL projects focus on sequestering carbon dioxide in depleted oil reservoirs. Some of these projects have the twofold benefit of sequestering carbon dioxide, while at the same time forcing hard-to-reach oil to the surface as a way to produce more energy. NETL on-site R&D efforts focus on capturing carbon dioxide and storing it in either geologic formations or the deep oceans.
We continuously analyze funding, research successes, policies, and a number of other factors to ensure that the sequestration effort is on the right track towards meeting programmatic goals. Any analysis we provide goes a long way towards giving decision makers the information they need to prioritize and direct continuing research.
When scientists cast an eye towards the energy systems of the future, they envision a nation powered by hydrogen. They see an extremely clean, abundant energy source fueling our cars, warming our homes, and powering industry. Their vision is not that far into the future. Already, automakers are producing hydrogen-fueled vehicles which emit only water from their tailpipes, while power plants use fuel cells and hydrogen turbines. To make hydrogen the fuel of choice in the future, scientists face some major challenges. While hydrogen in its myriad forms is the most abundant element in the universe, producing pure hydrogen gas is difficult and expensive. And once it's produced, hydrogen delivery and storage present additional challenges. To meet these challenges, the National Energy Technology Laboratory oversees a research and technology development program to advance the production and use of hydrogen from coal. Since America has vast coal reserves, coal is the likely choice to produce large quantities of hydrogen to meet the nation's energy needs.
NETL works closely with the private sector and with other government organizations to achieve the goals of the Hydrogen from Coal program. The common purpose is to speed the transition to a hydrogen economy in which hydrogen provides the bulk of the United States energy. NETL's participation encompasses coal gasification to produce hydrogen, carbon sequestration, and fuel cells to make electricity from hydrogen.
The Department of Energy supports development of an advanced system known as Integrated Gasification Combined Cycle. This system promises much greater efficiency than the coal power systems of today, which means more energy from the same amount of coal. It also produces large amounts of hydrogen that can be separated and collected for many uses. One way to separate hydrogen from other gases is by using membranes. NETL supports a number of projects to develop and test a variety of novel hydrogen separation membranes. Some projects have developed membrane materials that are ready for scale-up and long-term testing. NETL researchers have demonstrated recent successes with a new membrane material made of palladium and copper alloy.
Our in-house membrane test results have shown that certain membrane materials, resembling flat discs about 3/4 inch in diameter, to allow pure hydrogen to pass through without contaminating the membrane.
Of all the hydrogen end-use technologies, perhaps none have taken center stage as visibly as fuel cells. Their appeal is broad, from transportation to stationary power to industrial and agricultural applications.